Now we are going to study about the relationship between arithmetic mean, geometric mean and harmonic mean. Since mathematical proof is very easy, so I am showing it firstly the geometrical proof. As you know, the geometric mean and harmonic mean and arithmetic mean, the formula I have shown it to you earlier in my previous videos. So these are only the formula. You just don't look into this part because it will make you more confused. So moving on to the diagram, we have taken a circle, okay, and this is nothing but the diameter itself, and the point C is the center. We have taken the diameter, we have divided the diameter into two parts. The first part from this point to B is A, and from point B to this point is B. I have taken it like this. You can take point A from this to this or the remaining part as B. It's totally upon you, and experiment the same concept which I am going to show you in that particular segment as well. Okay, so now we have taken the average of point A and B. Actually not point A and B, because this is the whole segment is A and this whole segment is B. So the arithmetic mean is A plus B by 2, correct? So whenever we are finding out the average of these particular segments, this totally means that A plus B by 2 is the radius of the circle, correct? Because whenever we find out the average is the half of the whole segment, correct? And the half of the whole segment is what? The radius itself. So that's why, since point C is the center and this particular segment is the radius, so A plus B by 2 is arithmetic mean, correct? Now, as you can see, I have made another radius from point C, which is the center of the circle, on the circumference, which is AC. What is AC? AC is also the arithmetic mean. Okay. Now, what we have done, we have made a chord on point B, and this chord is perpendicular as I have stated. Now, as you can see that this is one chord and the diameter is the largest chord of the circle, correct? Now, these two chords are intersecting at point B, okay? So, in geometry, we have read that whenever two perpendicularly chords are intersecting, then the product of their intercepts are equal, correct? If you haven't read this theorem, then I am requesting all of you to write it down, okay? So as I've stated, the intercepts are what? I have taken this particular intercept from A to B is x, and from this to this point as x as well. Why I have taken both the intercepts equal? Because since the diameter is dividing the whole chord equally, because the diameter is what? The largest chord, and it's dividing from the middle. That's why both the segments are equal. Now this x and x, what we are doing nothing but applying that particular theorem which we have read in geometry. So the intercepts are what? X and x, x into x is equals to A into B, correct? X square is equals to AB. So taking the square on the other side, x is equals to root AB. Now, I think this is very familiar, right? You guessed it right. X is nothing but the geometric mean. So, AB is geometric mean and AC is arithmetic mean. Now, from the Pythagoras theorem, you know that the hypotenuse is always greater than the perpendicular, right? So AC is what? Arithmetic mean, and AB is geometric mean. So we can see from the Pythagoras theorem that arithmetic mean is greater than is equals to geometric mean, right? Absolutely correct, because we have making a right angle triangle from point B. So as you can see, the opposite one is always hypotenuse, right? So AC is the hypotenuse, and here is one proof. Now, what is harmonic mean? In order to prove the harmonic mean, we have made a perpendicular from the vertex B on the hypotenuse. Okay. So this is another theorem where we have read that if a perpendicular is drawn from point B on the hypotenuse AC, then the square of the perpendicular is equal to the product of the sides of the hypotenuse. Okay. So this is the result. AB square is equals to AD into AC. We have so many results, but we have taken only this because we were going to use this in order to prove the relationship between geometric mean and harmonic mean. Okay. So from here you can see what is AB square. AB square is geometric mean. AC is arithmetic mean. From here you can take out another result which is important, which is this one, where geometric mean square is equals to harmonic mean into arithmetic mean. I'm requesting all of you to write it down, this formula as well. Okay. Now, putting down all the formulas, we can find out that AD is nothing but the harmonic mean itself. Correct? So, here is the result. Here, this point is AD. This is DC. No, this is AC, which is arithmetic mean. This is harmonic mean, and this is geometric mean. Then how does this prove the relationship between geometric mean and harmonic mean itself? Because as you can see, we have drawn a perpendicular. So this makes a right angle triangle, correct? The opposite of right angle triangle is always hypotenuse. So AD is what? Harmonic mean, which is always less than is equals to geometric mean, correct? So here is our second result. Okay. I just hope you got this clear about the concept of geometric mean, which I have tried to explain it to you. Comment down below your thoughts and opinion so that I can clear it out. Thank you so much for watching. I'm signing off now.